Hey, that. And it works. Hey, cool. Heck yes. Sorry if you've been waiting. This rolling. Current viewers 1. Current viewers 3. I can find myself. Sick. Sorry about the slightly late start here. To update a ton of things to be able to stream on YouTube. But we're in. Hooray. Huh. My chat. Working how it used to. I'm down to 1 10. I'm so. It was not receiving enough video. Ever. Oh no. Sorry, folks. First stream of the year. I haven't used it in forever. Is a little sketchy. While trying to get this figured out. That looks fine. Okay. Different than when I used to. Sorry. My poor CPU overheating. Yes. Good. Do it, little buddy. Probably affecting the stream quality. Dropped frame 0? That's good. Why do I not have a chat? That is annoying. That used to be a thing. Wrong. Yeah. Because it's made for kids that I don't have a chat. That's pretty awful, though. What if I say no, it's not made? Now can I have a chat? Yes. Okay, cool. Sweet. There should be a chat if you reload now. And now stuff should be working. Fantastic. Hopefully it will continue to work. Hopefully I'm audible. Check that. Check. Yeah, cool. Hello. Oh no, Andrew Chappelle's here? Why are you still subscribed? And Rose, all sorts of older folk. Alrighty. So I've subscribed to all my favorite content. You're better than me. I'm terrible at subscribing on YouTube. So should get this started. Okay, so my streaming device is an absolute potato, so hopefully the sound quality stays nice. Otherwise, that would be sad. And there was a Rose Marsh and a Matthew Rubinstein in here. Wild. Where would folks want me to start on this here thing? Uh, while I'm waiting, I guess I'll start with the fun thing, which is, oh yeah, this changed too. And lovely, it's crashed. Oh, I love it, I love it. So hopefully this will work. Yeah. Okay. Mimi says hi, I know you're here. Oh, okay, sweet. The question I wanted to talk about in here was not A or B, which, come on, little buddy. Not gonna work? You can do it. There we go. Not in A or B, but rather in C, because a lot of people get to this in behavior thing and they're like, what the heck does this mean? But in behavior always means what's happening at infinity. And what's happening at infinity is this function is going to a ratio of the leading power terms. That's always what happens at infinity. And x cubed divided by 3x squared is x over 3. And x over 3 is a linear function, 1/3 x, a linear function with a slope of 1/3, which means as this horrible fraction thing is going out to infinity, it does some sort of janky stuff here around 0. Doesn't look like this. But as it goes out towards infinity, it starts looking like just a straight line that has a 1/3 slope. And so that's the end behavior model. G of x is just this 1/3 x thing as we go out to infinity. And so it's going to infinity in a linear fashion. Now, slant asymptotes really aren't that big of a deal in calculus. They don't really come up on the AP test, but it is helpful to think about in behavior when thinking about how big things are, and this thing is not going to infinity quickly. Like something like 2 to the x is going to infinity way faster. Something like x squared is going to infinity way faster. But then the next question says, what's the limit as x approaches infinity of f of x, which is this original function? Since the power is bigger on top, and like we could see that from our end behavior model, we're just going to infinity. But what's the ratio of the original function and the end behavior model? Well, this model's entire point is that's what this function looks like at infinity. So if I just divide the original function by the end behavior model, I'm just going to get 1 because they're exactly the same. And so that looks scary. But it isn't actually that evil, this last question here. All right, Mr. Kennedy, Andrew and I can't access the review. I know, sorry. Does Canvas keep freezing? Canvas. I failed differential equations twice and changed my major to geology. Well, I was excited about the geology change, but I'm sorry you failed diffie-qs twice. That's rough. But how does this pen tool work now? Can I just stop inking? Goes away? No. Eraser. Okay. What is your zodiac sign? I don't know. That's some demon magic. I'm not going to answer that crap. Yo, is this math or something? It is. How has nobody in my class given me a question? Can you go over g of x? I wasn't there for it. Oh, g of x is just what this function looks like at infinity. And what it looks like is a ratio of your leading terms, which is x cubed over 3x squared, or x over 3. And so that's all g of x is. It's a linear function as you go out to infinity. No, I think it's history. Eh. I am so confused. Hey folks in class, what kind of stuff would you want to know about for this test? That's simple. It is. Can you go over A in this? Sure. What are the zeros of this function? The top factors to x times x plus 3 times x minus 1. And the bottom factors to 3, and then x minus, or x plus 2 at x minus 1. And so x minus 1 over x minus 1 is a whole, so it can't also be a 0, because when you plug in 1, you don't get 0, you get 0 over 0, which is a whole. That's a discontinuity. There's a hole in the graph there. Can't be a 0. So our only zeros can happen at these two spots. Zeros are normally where the top is equal to 0. I probably should have started with that. But we can eliminate the 1 because it is a whole. It also makes our bottom 0. And so that's no good. Okay, can you go over 4? Sure. What happens if I happens if I scroll this? Oh, cool. Oh, that's how that worked. That's hype. Alright, can you go over 4? Yes. I assume this is 4. There's not another 4, right? Yeah. Cool. So in 4, it just says, what's the limit at infinity of this function? And since the power is smaller on top than it is on the bottom, it would just be 0. Justify your answer. Power is smaller on top. And what can you conclude? The thing I'd conclude based on the limit at infinity being 0 is that I have a horizontal asymptote at 0. Horizontal asymptote of y equals 0. No, section 4, not number 4. Oh, rip. All right. So question 1 on the first page. This homie right here. You missed the hints for this one. It involved the conjugate to get this. Or honestly, this one's one we could do L'Hopital's already for, if you've heard of that thing. But the conjugate here would be square root of x plus 5 plus 3. And you'd multiply that on top and bottom. And the benefit of this is that when you multiply these, on top you just get x plus 5 minus 9. The first thing squared minus the second thing squared, because the two middle terms cancel. And on the bottom, you get x minus 4 times x plus 5 square root plus 3. All this stuff. So this doesn't look easier until you realize the top is x minus 4, and those cancel. And now all we get is 1 over the square root of x plus 5 plus 3. And now we can plug in our limit from the beginning by plugging 4 in for x, and we get 1 over the square root of 9 plus 3, 1 over 3 plus 3, which is 1/6. And that was the fat pile of work for that. Who's my favorite TA? I have none right now. Alright, I am going to go over section 4. I'm not ignoring you, Marcus. But I am going to zoom... Gosh darn it, I keep forgetting to shut off the pen before moving. To page 2, letter A. Page 2, letter A. Oh, I have the work over here for that one. Which is that... for letter A, all I did was look at where the top equals 0. And I couldn't choose all of them because x equals 1 was a whole, which means it's not a 0. So it was only 0 and -3 for the zeros on that one. I think that is the question you had, Arya. Okay. Section 4 is limits at infinity. So technically I've already done a couple of those on here. It's also limits at infinity and 0. So for example, question 6 here, 5 and 6 both would be examples of things that could be in that quiz section. I think that's right. No. Section 4 is, Section 3 is limits at infinity and 0. Section 4 is the limit definition. So, does this work again? No? Okay, so then it means I have to write in Word. Rip, stupid computer. Computer is such a potato. Alright. So the limit definition is the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. When will the answer key be posted? It is posted on Canvas. So, when is it posted? Now. It should be on Canvas, just under the module for today. I'm looking at it. Chapter 1 answers, review answers.docx. If I click on that, did I post the answers? Yep. And in classic Mr. Kennedy ADD fashion, I didn't actually finish the bottom question, and the entire bottom question is both not finished and the first part is wrong. Oh, that's really funny. Well, good thing I talked about it. All right. I wanted to talk a little more about this limit definition, then I'll get to the other questions. So yeah, everything except that bottom question is right on the answer key, and I'll talk about that in class. That was why you don't have ADD. All right. Limit as delta x approaches 0 of f of x plus all this stuff. If you want to use this on any function, let's say I try to use this on x squared minus 4. Then I would plug in x plus delta x squared minus 4. That's f of x plus delta x minus x squared minus 4. That's f of x. All over delta x, limit as delta x approaches 0. And then you just expand the top and cancel stuff out and get to the answer. Yeah, Carter, look at my factoring in that and don't criticize it. It's really wrong. That's why that one's wrong. Anyways, if you expand this, you get x squared plus 2x delta x plus delta x squared minus 4 minus x squared plus 4. And then if you cancel the like terms, x squared minus x squared, 4 minus 4, you're only left with these two homies. Kind of the big idea is that at this point, you always get to a point where you can cancel out the delta x because every term on top has a delta x in it. A lot of people try to cancel out the delta x without that happening, but the beauty of subtracting f of x is that this stuff will always annihilate. So all you're left with is 2x plus delta x, and then you plug in the limit as delta x approaches 0. And this part becomes 0, and you just get 2x, which we know is the derivative of x squared minus 4, because we know the power rule. Oh man, I just went off the screen. Alright. And then the other side of this, the other kind of section 4 questions, are where I give you a question. So limit as h approaches 0 of, what should I do? Like 2 cosine of pi over 6 plus h minus, what would that be? Root 3 all over h. This is the same type of question, except with h's instead of delta x's. And in this type of question, your goal is to pull out what the function is. And 2 cosine of pi over 6 is the square root of 3. why there's a square root of 3 there. So I know 2 cosine of x is my function. And since the limit definition means take the derivative, I'm going to take the derivative of this and get negative 2 sine of x. And then I'm going to plug in pi over 6 for x. And so I just get negative 2 times 1/2, which is what sine of pi over 6 is, which would be negative 1. And that would be my answer to this question. So this is forwards. Oh my gosh, I went off the page again. Sloppy. Negative 2 sine x is the derivative. You plug in pi over 6 and you get negative 2 times 1/2, which is a negative 1. This is all section 4, quiz section 4. So there's the forwards where we actually solve using the limit definition, and there's the backwards where we're given a question in limit definition format, and we got to use the derivative tool in order to solve the question and actually get a value out of it. So which one am I doing? None of these, but who asked me about this? It was Marcus quite a while ago. So this is limit definition, and this stuff's definitely on the test. Although I probably wouldn't give you a cosine derivative because that's a little bit too hard. But I would give you a derivative like x squared or something like that. Okay. Let's go back and find the next question. Can you re-explain horizontal versus vertical asymptotes? Sure. Oh, whoops. See if I can find another empty space on this document. Come on, computer. Oh, crash. Word is not responding. Oh no, that's the bad pop-up. I just have to switch to my desktop. Is my little engine that could not gonna make it? Come on, buddy. Try to open a different Word document and write in that one. Why are donations off? That seems sketch. Alright. I'm going to open up this Word document to answer that question, because here I have room, and it's not crashing. So, horizontal versus vertical asymptotes. Okay. So, horizontal asymptotes, these are always limits at either infinity or negative infinity or both. There are weird functions that have a different asymptote at negative infinity than positive infinity. That's why I include both, but most of the time it's going to be the same limit at infinity or negative infinity. For instance, if it's like x over x squared plus 1, the limit at infinity of this thing is 0, and the limit at negative infinity is also 0. So this one would have the same one from both sides. Another example of horizontal asymptotes is like an x squared plus 3 over 3x squared plus x. If I look at the ratio of leading terms, x squared over 3x squared is 1/3. And that's our horizontal asymptote, is y equals 1/3. Horizontal asymptotes are always y equals number sort of things. And they're either going to be 0 if the power is smaller on top than it is on bottom, or 1/3 if the power is the same on top and bottom. Or in the case of something like e to the x, or any exponential, has a horizontal asymptote of y equals 0 because it looks something like this. That's an asymptote there. That's another. Sometimes asymptotes are built into the functions we have. All right, vertical asymptotes is simpler. There are two sources we have for vertical asymptotes. One of them is the bottom of a fraction equals 0. So if I have like something like this, x plus 1 over x minus 1 times x minus 2. X equals 1 and x equals 2 are my vertical asymptotes. And vertical asymptotes are always x equals sort of equations. The other example of a vertical asymptote that we have is the natural log of x function, or just like any logarithm, which has a vertical asymptote because, for the same reason exponentials have a horizontal asymptote, the natural log graph looks something like this, and it always has a vertical asymptote at where its values start actually existing, so where the inside becomes positive. So it would be at x equals 0. There's a vertical asymptote for the natural log function. So horizontal ratio of the leading terms, exponential where it flattens out, or smaller power on top, bigger power on the bottom. Vertical asymptotes where the bottom equals 0. Slant asymptotes only exists, by the way. It's not going to be on the test. But when the power on top is 1 bigger than the power on the bottom, so you can have a linear relationship as they go out to infinity, this thing will look like x. Hopefully that explains that question. Well, can you also explain how to tell if the limit is negative or positive infinity? Negative? Okay, I think I kind of know what that question's asking. See if I can find another blank space. Well, I have a bunch of example questions here, but y'all did this. So, do you know why the fire alarm went off? Yeah, it was probably your fault. I don't know. I have no clue. Okay, so to tell whether or not a limit's going to positive or negative infinity, examples where this is like really relevant is good example. Something like this. Ooh, this is a fun limit. Yeah, actually, I want to talk about this limit. So this is a really good case for telling sign, because the limit as x approaches 0 for the absolute value of x over x is one of those fun cases, because if you plug in numbers just to the left of 0, like 0.0001, what you're going to get is like positive small over negative small. And those numbers are going to be the same because it's x on top and x on the bottom. So we're going to be going to -1. However, if you plug numbers on the positive side of this, 0.001 or something like that, you're going to get positive small over positive small, which is +1. So this graph is actually looking like a step function, sort of. It's -1 for all negative values, and then it hits here, and there's an open circle, and then up here, another open circle, and then it has a 1 slope every time after that. This is one of those, be really careful around 0. Another example of this is if you have like limit as x approaches 0 of the square root of x over x, or something like this. This one, you can't plug negatives in square roots, so it goes straight undefined from the beginning. Oh, by the way, this guy is also undefined. So those are some weird cases. Now, at infinity, which may have been what you were asking, if I have the limit at infinity of, what should I do? Something like this. Square root of x squared plus 4 over x minus 2. As I go out to infinity, the dominant term is going to be this x squared homie. The square root of x squared is just x. So this is going to look like x over x, and it's just going to go to 1 as I go out to infinity. But if I go to negative infinity, for the same function, on top, I'm still going to be going to x, because if I plug a negative number into a squared, it's going to become positive, and then what I'm going to get out is just a positive value of x, because the square root of a squared number is definitely positive. And on the bottom, I'm just going to get x, and so if I plug negative infinity into this, I'm actually going to get a positive number over a negative number, so this is going to go to -1. And so you have to be really careful when dealing with signs, that when you look at the biggest powers on top and bottom, that you're accounting for the fact that maybe one of them has to be positive and maybe one of them doesn't have to be positive. So these both had limits. This had a limit of 1 at positive infinity, a limit of -1 at negative infinity, whereas my two zero cases did not have limits because there's like a jump discontinuity. I guess it was just one zero case? No, there were two there. The limit at 0, undefined? Absolutely. Can you do 15 on the chapter review? Let's see if I can answer that question. Yes. Yes, it uncrashed! Hooray! There was much rejoicing. Alright. Wait, did it uncrash? Alright, yeah, go to bed. Close you. Yeah, we can go ahead and crash everything. No, I don't need you to send something to Microsoft. Cancel. And now I can restart this and it won't be absolute crash. Sick. Alright. Uncrashed. Feels good. Question was 15. This is why the district should give me a better computer. Yep. This computer is such a piece of garbage at this point. Maybe I'll pony up and pay for it myself. Seems like a quitter's way, though. Okay, so 15. Let the function be defined by all this garbage. All you had to do in this was test 0 in these two functions. So sine of 0 is 0. X squared is 0 at 0. So the limit at 0 exists. That checks out. It's the same value from both sides. At 1, if you plug 1 in, you get 1 squared is 1, 2 minus 1 is 1. So those match. That checks out. 1's chilling. And at 2, if I plug 2 in, I get 0 in 2 minus x. And I get -1 in x minus 3. Those don't match, so that's garbage. So it was only 2 where we had an issue here. Also, none of these functions are discontinuous. Do make sure you check those. Those could have an issue. Like, for example, if this had been 1 over x plus 1 instead of sine of x, it would have had an issue at -1 also, and I would have had to talk about that one. All my homies hate the district. I don't know how to interpret that. Go over 13, the intermediate value theorem one. Yes. So, the way intermediate value theorem works is you do f of 2 minus f of 1. The reason why I'm doing 2 and 1 is those are the points. Basically, you always do f of whatever this value is minus f of whatever this value is, the second and the first. Y2 minus y1 over x2 minus x1. And you see what... wait, am I goofing? No, I am so talking about something that comes later this year. My head went crazy. You just need to figure out f of 2 and f of 1. That's it. So if you plug 2 in, 2 times 2 cubed minus 3 is 13, because that's 16 minus 3. And if you plug in 1, you get 2 minus 3, which is -1. Okay, so to use the intermediate value theorem, first thing you gotta say is, this dude is continuous. You have to have continuity or the intermediate value theorem doesn't work. Once you know that, you know you're going from -1, 1 to, wait, 1, -1, gosh darn it, I got those backwards, +1, -1, to 2, 13. So you know you're going to all the y values in between those. So 1, -1's here, 2, 13's here, and we're going through all, no matter how I connect these with a continuous function, I'm going through all the y values in between these 2 points. I could be going to y values above or below, like I could originally go down, and then I could go like way up, and then I could go back to that point. But all that's guaranteed is exactly all the y values between those two, which happens to be 0, is between -1 and 13. So 0 has to happen thanks to IVT, or due to IVT, or because of IVT, or whatever, the intermediate value theorem. So basically, if the function is continuous on the interval, it will have all the values from f of 1 to f of 2. Yep. So check if 0 is between those, and that's how to prove it. Exactly. That's the intermediate value theorem. Yep. Yeah, my explanation didn't make sense. Just look at Arya's, because that's a pretty good explanation there. So you don't need to make y 0. Exactly. No, you don't need to make y 0. There's actually a really janky question that came up on one of the other things. Where was that? Was one of these two. Can I actually write on these? Yes, because DS also have that. This question was super janky if you did this one, because works, right? Oh, that doesn't work as a writing tool. This one. Add signature. Oh no. Oh no, what is this? Close. Can I write on this? Maybe this one will work. Alright, swear word. My screen sketch usually works, but when my processor gets overflowed, it doesn't work anymore because this computer sucks. So, okay, this question right here on the screen. If you plug in 7 pi over 6 into sine, you get -1/2. And then if you plug in 7 pi over 4, you get -√2 over 2. So it says, by the intermediate value theorem, g of x must equal what value for something on that interval. And by those two values, all that's guaranteed is a value between -1/2 for the first one and -√2 over 2 for the second one. And that's it. So none of these values, neither a nor b nor c nor d, are in between -1/2 and -√3 over 2. So this question was actually trash, because none of them work. Even though, if you know your unit circle pretty well, -1 definitely is a value of sine of x at 3 pi over 2, which is on that interval. It is not guaranteed by the intermediate value theorem. So this is a jank question that I think does a good job of testing whether or not you know what intermediate value theorem is. So a is a value that is on that interval, but it is not guaranteed by the intermediate value theorem. Yeah, so Sydney, you're gonna have your work cut out for you. I've heard you collect quotes, and you're gonna have way too many from me. Uh, I talk differently than other humans, so that can be an issue. Ken Buckley energy. Uh-oh. Can I go over A, B, C, and D? Yeah, I was going to do that again, but I was going to kind of wait till the end and just try to go over other people's questions before I, like redo stuff. Got 400 from Level last year. Yeah, I'm pretty sure I talk weirder than Level, though, which is unfortunate for me. Can you go over the last four again? Yeah, I'll go over ahead and do those right now. Let's see. Oh, gosh darn it. So to go over the last four in order, since the answer key is trash for these. You had to factor this: x times x minus plus 3 times x minus 1, and 3 times x plus 2 times x minus 1. And cancel out the x minus 1s, that's a whole. So it's neither a vertical asymptote nor a zero. That's why I sort of canceled it out for the sake of this one. So the zeros are 0 and -3. Like x equals 0 and x equals -3. The vertical asymptotes are at x equals -2 only, because that's the only spot that's not a whole that makes the bottom 0. The in-behavior model is just the ratio of the leading terms, x cubed over 3x squared, which is just x over 3, which is a linear function, what g of x is. And then the limit at infinity of this function, since power is bigger on top than bottom, is infinity. And the limit at infinity of the ratio of f of x to the model is, since the model is supposed to model f of x, is 1. Ratio is just 1. I know it said 0, 1 on the answer key. The answer key is like omega wrong. I got super distracted. How long is the stream gonna last? Yeah, definitely no later than 8 o'clock. How long? Can you go over 3? Yes. Can do that. Stop inking. Roll up. Find something that says question 3. Sick. Alright, question 3. If you plug in pi over 2, you should have gotten, because cotangent is cosine over sine, you should have gotten 0 over 0, because the bottom 0 and the top 0. But if you rewrote cotangent as cosine over sine, you probably notice that you can cancel out the cosines, which means you have 1 over sine, pi over 2. Or that's also just sine of pi over 2, which is 1, which is the answer to this. Because I'm allowed to cross out these cosines because that's where the whole is in this function. The whole is the at pi over 2 because of the cosine. Sorry, I meant 3, the first question. Ah, rip. See, this is also my fault because I make answer keys that are like amalgamations of a bunch of different things. Alright, or sorry, answer keys. Review assignments. So for x is greater than or equals 0, the horizontal line y equals 2 is the asymptote of the graph. Which of the following statements must be true? If we know we have a horizontal asymptote, then we know the ratio of the leading terms is 2. So I could whoops, that's not how you make a ratio of leading terms that's 2. It's actually like this. So we know we have some scenario like this that's making us go towards 2. And the other thing we know is that horizontal asymptotes are just limits at infinity. So I know my limit at infinity is 2 because I have a horizontal line 2 that's an asymptote. And that's all you really need for that one. The other ones are all not necessarily true, but possibly. Char. My bad, Michael. I was wrong on this. Uh-oh. Because you used an emoji, it got flagged for review. Charlotte. Pronounced Shar. Oh, okay. Wait, why is B wrong? Um, you could have that point defined on your graph. So, for instance, I could have. So what's a good example? I'm gonna use like 2 plus 2 to the x as my function that has a horizontal asymptote of 2. So here's 2. And then 2 plus 2 to the x looks something like this. And then what I could do is I could say my function looks like this for x is not equal to 0, and at x equals 0, I have a value of whatever I want. 7. Also, I guess B is wrong because it says f of x isn't equal to 2, and check out my graph, it's not equal to 2 there. It's like always bigger. It's 3 here, it's 4 here, and then it goes up. So it's never equal to 2 for any positive x value. Is there a time limit on the test? Yeah, you get the whole period. That's a time limit. So, yep. Yeah, I could make this thing have any value I want at 0 if I wanted it. Even though I have this, I could make it be 2, and I could make this one be true. But the point is, I could make all of these be true if I wanted. Like, for instance, I could make this thing be equal to 2 at this point, like I did here, and all of a sudden, even though I asymptote to 2, I also touch 2 at a point. Another example of something that you asymptote through but go through constantly is sine of x over x. If you look at sine of x over x, that's cosine, not sine, whatever. It gets smaller and smaller and smaller, but it's constantly going through its asymptote. And so this is another example where you can totally go through the asymptote. Not something you can't touch. Test is 4 pages, that's right. Can we leave when we're done? Come, Carter, this isn't online school. No, you can't leave and wander the school. Like, come on, man. How do we use Hooke's law in calculus? I don't remember what Hooke's law is. Hooke's law. You use it in Calc BC, but also Hooke's law is like a linear relationship, so yeah. Chillin'. Can you list the topics covered on the tests? Yeah. All the algebra reviews, but like it's just going to be a little bit of all the algebra reviews. And then it's also going to have sections 1 through 4 with a touch of 5, but mostly just 1 through 4. The reason why I say a touch of 5 is all the limit definition questions. If you know the power rule, you can check your answer. And some of them, like for instance, this kind, where it's like limit as h approaches 0 of x plus h cubed minus x cubed over h. This sort of question, if you use the power rule, you save yourself so much time. You just get this as a multiple choice. Yeah, you're chilling. Because you can just pull out the function as x cubed and take its derivative, which is 3x squared. So that's where power rule can show up. Otherwise, yeah, just mostly these quiz sections. More or less everything we've done so far. How long would it take for you to take the test? Probably like 10 minutes. Probably closer to 5 minutes, but yeah, somewhere around there. This test is very fast for me. Most, like, all the algebra review quizzes took me, like, under a minute. So we could use whatever formula for the multiple choice. Yeah. Only the only place where you're gonna have to do the limit definition, like the long way, is in the quiz section on the last page. Everything else is going to be pick your favorite method. You should take the test too and time yourself. I mean, I'm probably gonna take it tomorrow morning, because, like, the reason why I don't take the tests, like, with you guys is most of the time I've taken it twice already to proofread it, make sure there are right answers. So, yeah, it's mostly gonna happen, like, at 8:30 tomorrow morning, or 8:20. Early. Power rule for the win, I agree. Alrighty, I think we're done. It looks like questions are cooling down. Also, Sajana, it's f equals negative kx usually, because there's an inverse relationship, but I guess kx can have a negative. Nancy requested to go over logs, but she cannot comment, so here. Okay. I can do a couple log rules. Why are we doing anything nice for Nancy? That seems oh no, it crashed again. Alright, to a different document. Nope. Are we back? Believing. Oh, I have no belief. Computer's such a potato. Alright. Erase, and then use the space in this non-crashing Word document. Alright. Some real quick basic log stuff. Good job, computer. Some real quick basic log stuff. Really important things. Log base 3 of x is the same as natural log of x over natural log of 3. That's really useful. This allows you to change anything into a natural log. Second thing. If you have logs that are added together, you can just multiply their insides and combine them into the same log. If you have things that are subtracted, you can divide. So if this was subtraction, it would just end up being log base 2 of x over x squared. What other log rules do we have? I guess logs in general, log base 7 of 49 just means what power do you raise 7 to get 49, so it's 2. I don't know, there's not a ton of other log things that are super relevant. Nancy is so mean. Yes, I agree. Yeah, Sajana slacked in Calc BC. Sajana should have gotten a 5 on Calc BC, but, you know, whatever. 4 is worth the same amount of credit everywhere. Alrighty. This test is going to get ugly, ladies and gents. Hopefully not. Hopefully not. But maybe. Too bad. Yeah, I mean, whatever. It's good enough. Alrighty. Have a wonderful rest of your night. And yeah, I'm gonna try to figure out how to get less of a potato.